LA's first choice of news, Eyewitness News, at 6, with Scott Reif, Traffic, Garth Kemp, Weather, Rob Fukuzaki, Sports, and Bryce Shawcross, Medicine.
Good evening, this is Rob Fukuzaki with your sports update. And Frank, factor of... I'm sorry, it seems we have some
breaking news.
Good evening, this is your medical correspondent Bryce Shawcross here with a breaking news update. Recently, Dr. Oz was seen on Oprah's show discussing the effects of pluripotent-induced stem cells. Oprah was shocked and said, and I quote, "I don't understand, please explain this to me." Dr. Oz failed to explain this to Oprah, and Oprah does not understand, but here at Eyewitness News we are going to bring the story right to you and explain how it can affect you in this harsh economic climate. What is induced cell pluripotency? Cell plurality is the ability for one single cell to become almost any other cell in the human body. Induced pluripotent stem cells, commonly abbreviated as iPS cells, or iPSCs, are a type of pluripotent stem cell artificially derived from a non-pluripotent stem cell, typically an adult somatic cell, by inducing forced expression of certain genes. To better understand the process, let's look at an overview of the situation. In this case, a mouse with sickle cell anemia had skin cells collected. These cells were cultured and then reprogrammed into embryonic stem-like iPS cells by adding OCT4, SOX2, and a variety of other gene-altering viruses. How do we insert these genes? First, donor cells are isolated and cultured. Then, we transfect the stem cells' associated genes by viral vectors. To transfect is to infect a cell with purified viral nucleic acid, resulting in subsequent replication of the virus into the cell. Viral vectors are a type of virus that act as a transport machine into a cell. The type of viral vector utilized is a retrovirus, or a reverse transcriptase, which allows integration into the host genome. This is literally the opposite of DNA's transcription. When DNA is transcribed, it's turned from DNA into RNA. By reversing this process, you're literally reprogramming the cell, turning single-stranded RNA into double-stranded DNA. These genes include OCT3/4, SOX2, and a variety of others that I'm not going to try and pronounce. Now we're on to the next stage of the process. From the batch infected by the viruses, only a few have their DNA completely reprogrammed. These are then isolated. They are now identical to stem cells. Success. Unfortunately, the gene CMYC is oncogenic and caused cancer in 20% of the mouse subjects in the initial test. This process was later repeated without the gene CMYC, using only 3 of those genes. Although the process takes longer, this does not create cancer. Is this a viable option? Genetically altered cells of a patient have a dramatically lower rate of rejection than that of a person in the case of a transplant. Because you're not accepting these cells from a donor that is not you, there's a far lesser chance of rejection. Is this more desirable than other methods? By using a person's own cells to create stem cells, the moral implications of stem cell research as we know it are removed. Embryos are not needed. Also, with the removal of the gene CMYC, there is little to no chance that this could cause cancer at all. What diseases can this benefit? This research can help cure many diseases and injuries, including spinal cord injury, diabetes, heart disease, Parkinson's disease, Alzheimer's, Lou Gehrig's, lung disease, and arthritis. This research has already begun. The Food and Drug Administration has approved human tests of stem cells to repair spinal cord injuries. The future of induced pluripotent human stem cells is looking very bright. This is Bryce Shawcross with your Medicine News Update.
That was an Eyewitness News special report.
In other news, the NHL had a surprise today when their star player, Now it's time for that thought-provoking question. If we can now engineer our own cells by rewriting their DNA, what are the scientific limitations that come into question? How much rewriting of our own DNA, thought to make up who we are we allowed to do? Is there an ethical boundary we're crossing by reprogramming the building blocks of life?